So I made some changes to the trim since the first video when I first came on site earlier this morning. Biggest things I changed was there was actually a plugged restricted orifice on the alarm gong side there. I plugged it off. I ended up installing it right here on the actual flow switch port. I ended up piping the flow, so I installed the restricted orifice right here. I made sure to install a 1/2-inch check valve downstream of it so that if I'm doing a main drain test or potentially draining the priming water off, I'm not going to accidentally back pressure my own alarm line and cause my flow switch to go off. So I've piped that in. I've added, before I actually ran into the issue, I didn't have a means of draining the priming line, so I have since done that. I've hard piped one into this drain. Yeah, that's pretty much it. And I moved the ball valve. Before, the ball valve was on the supply side of the flow pressure switch. We don't like to do that. That's it's bad juju. Basically, if you ever forget this ball valve closed and it was before my switch, essentially you can actually have a flow alarm in the building and no one's going to be notified because you've killed off the pipe prior to. So I'll quickly show you. I ended up in the other video, or maybe I don't know if I can edit it or whatever. The ball valve used to be basically right here off of my alarm line. There's my alarm line. Kind of, where am I looking? Sorry, there's my alarm line. I'm trying to look at the video here. Into my velocity drip, across a check valve. Hopefully that works and holds. Alarm test valve. Before, my ball valve was here. So I got rid of that. I piped it over here. There's my flow switch. I got a restricted orifice. Always put a union close by if you can. I like to put unions nice and close to restricted orifices. They're just known to get plugged. That happens. So put a union there. I put a check valve here because I ended up doubling up. So here's my water priming fill cup right here. I just relocated that. This fill cup used to be kind of back here amongst everything, and I don't like doing that because now you're kind of fiddling with a cup. Bring it in front so it's easy to fill. So that's closed. I added a new composition disc globe valve straight right here, so now I can actually bleed off that priming line at the same water elevation. So that water now comes down this way. I've tied it into the same drain line as my alarm line, but as I said, I installed a check valve, so we're not gonna have any issues there. And then I just piped it into my 2-inch main drain and off we go. And I moved that ball valve on the alarm line over here. That was where the old restricted orifice was. It was a 1/4 inch one going into my water motor gong up there. Honestly, I didn't want to get into moving this toolbox, so I just moved it over here where I could reach it. It's only one system, so it's okay. It's fine how it is. So yeah, we're gonna get into just testing this flow switch. I did just finish installing that PCBS switch. Again, all 3 switches are the exact same in terms of electronically how they work. It's like a light switch. It's on off. That's it. It's open or close contact, and that's all there is to it. So just to kind of show you, this is also a PS10-2. I can't remember off the top of my head what pressure settings they're good for. I think it's somewhere between 4 and 12 PSI that you can adjust them to. There's an adjustment knob here. We've got a city water supply, but as I just mentioned before, I like to just call it water supply pressure of about 63 PSI. So it doesn't matter where I set this, it's going to go off. Because like I said, the minimum pressure I think is like 4 pounds, maybe it's 5. And the maximum I think is around 14. I'd have to double check the manufacturer's literature, but I know it's somewhere around that range. So I do like to just give the switch a little bit of tension on the spring, just so it does actually require a little bit of force on the acting diaphragm to change the switch's state. If you put it to practically nothing, theoretically, there's almost no spring tension. So, an old man blowing on soup could essentially set that switch off. So just give it a little bit of something. If you got 60 pounds on your incoming, it's going to, that's for sure going to trigger the switch. And just to show you again, you've got COM 1 and 2. 1 and 2 is the exact same as normally open, normally closed. You just got to figure out which one's which. Maybe not you, but the alarm tech. And it's 2 poles. So there's a pole on this side. There's a pole on this side as well. Same idea as what I said with the PCBS. If you wanted to, you can use this one switch to actually go to 2 separate entities. So they're for sure going to wire this to local monitoring, this flow switch. So they're going to bring that one set of wires coming in probably here, definitely here, They're gonna tie it into most likely this set of contacts because it's easiest to get to. And they're gonna go to their panel, or I guess to their box. And if they wanted to, they could also use the other set of poles, come back down. They can wire this up to 120 volt and ring a 120 volt bell or something. So they can use one switch to kind of double up on features. And theoretically also, if you potentially someone fails a flow switch, you can always check it with a meter and see if it's just this set of poles that have gone wrong. Maybe you can tell that, you know, you're gonna change the switch's state and you're gonna get no response on these set of contacts, but then you put your meter on the other side and the contacts do work. So rather than changing the switch, you could always just move the wires over to the opposite side and test it again. If it works, your panel receives the signal, then, you know, no harm, no foul. It still works. You've got a 50% switch, or at least I mean, I guess if I were you, I'd still change the switch, but in a pinch, if you don't have one, you can at least tell them that the switch works and prove it. You can do another test. So I'm going to, same as before, it doesn't matter what leads you go on. I'm just going to go on continuity just so I can hear it. Oh, it's too far. Let's see. So common 1 is closed. We're going to go to common 2 is closed contact. So you can hear it's beeping. If I go to the opposite side, if I go to common 1, it's open. So basically, once I send water pressure to that switch, it is going to change the state. So if I've got it on common 1, right now it's not making a sound, but when I put pressure on it, it will make a sound. Vice versa, if there's no pressure on it and I hear a sound right now, I can put pressure on it and it will remove the continuity. So it's like a light switch. It's either on or off, and you just choose electronically how you want it to be set. So realistically, all I want to do, I just want to make sure that when I flow water, this is going to change states. I am actually going to tie these down. So whenever you're working on dry systems, don't just go right ahead and open your alarm line. So I think, how am I going to do this? We're going to use common 2. I changed my mind. We're going to use, instead of open, we're going to use closed. Okay, so right now everything's actually normal and I've got a closed set of contacts. When you open an alarm test on a dry system, there is a check valve right here that is supposed to stop that water from putting pressure on the intermediate chamber. I don't always trust that, so we're actually going to do 2 things. I'm going to close this valve almost all the way, just enough. I'm going to keep open enough where I will still allow water to get through my alarm port, but closed enough where if it does happen to trip, because if you look at this velocity drip, I don't have a whole lot of faith in it. I don't know if it actually works the way I want it to work. And that's an OG check valve, so I don't know if I trust that either. So it's better be safe than sorry. I don't want to trip this valve because that will kind of suck. Actually, I kind of wish I started with the low pressure now, but. So here we go. We know that we are getting some water. It's not so bad. We're getting something. So at least if this valve does trip, I can quickly shut it. I'm not going to flood this system with too much water. Anyways, so before you open the alarm test, you should get into the habit of pushing this velocity drip closed. The way velocity drip works is when pressure enters the supply side of the velocity drip, there's a stainless steel ball in here that actually seals up when it's under actual pressure. So water should not be coming out of this during a flow condition. If there is a small pass of water, like say for example the clapper is leaking a little bit, it's not under pressure but you got some water coming out, that water will bypass that stainless steel ball or whatever, that ball, and it will just start dripping. So if you see a drip coming out of here, you know there's actually something inherently wrong. Most likely it's the clapper backing up a little bit. But yeah, so getting yourself into the habit, when you push that button down, this spring down on the velocity drip, you're actually forcing that stainless steel ball out of the way so that if this line does pressurize, it's not gonna, that ball is not gonna seal up. You're basically ensuring that water will for sure drain out of here. So that's always best practice. So we're gonna do this. I'm gonna open this alarm line, and when I do, water's gonna flow through my gong over there because I left that valve open, and I should actually hear this beeping stop, or this signal. Oh, it's tight. Yep, So there we go. It changed state. It's not ringing when I open this up. Yep. Stop ringing. I close this up again, and it's ringing. So there we go. We've now tested our PS10. Very simple. I explained how it works. So we know that switch is good to go for our fire alarm techs. They can come in, wire it up. They will decide based on their panel whether or not they want to use common 2 or common 1. Put their end of line, their resistor over that, whatever. Sometimes they'll go to another box. It's up to them. Decide how they want to do it. Maybe they're not even using an end of line. Maybe it's Class A and they're gonna use 4 sets of wires. So whatever. That's that. We've tested our PS10. I'm glad I didn't trip it. That's fantastic news. I'm gonna put that back on for these guys. PS10. I actually don't know if this is going to be fire alarm techs. Actually, I think it's just gonna be these ADT guys or whatever. Sometimes these guys don't actually know what the difference between all these switches are, so it will be nice. We're going to label this and we're gonna write Waterflow. And I'm gonna put alarm. And for this is a low pressure switch. So I'm just gonna put low pressure. And I'm gonna write supervisory. It wouldn't be a dick move if I switched the boxes on them. And this is going to be, I'm blocking it. I'm just gonna label this our, what should I call it? Main SV supervisory, main shutoff valve. Sure. Main SV. Or, yeah, sure, whatever. Main SV supervisory. Or supervisory. Oh, what am I hitting there? Hitting a bump. There we go. So now when these guys come to wire this up, if they don't know what the switches do, they will at least now know. I've labeled it for them. They should at least say, okay, this one's a supervisory alarm or supervisory signal, whereas this one needs to be a full-fledged alarm. So there we go. We've now tested our PS10. That's all there is to that. And we're going to jump onto the PS40, the low pressure.